Hey everyone. Alright, today's video is going to be over box plots, and these are also known as box and whisker plots. Your objective: I will be able to read and interpret a box and whisker plot. Alright, so a box and whisker plot is a graph that displays centers and a range of data distribution on a number line. I'm going to use this picture of a sub sandwich to show you how a box and whisker plot works. So let's say you have this sandwich and you have a friend who's really hungry, and you decide to be nice and split your sandwich in half with that person. So that means you would get to keep 50% and your friend would get 50%. Now let's say you have another friend come along and they are really hungry. So you have the half of your sandwich and you decide to split that in half with your friend. So that means you each have 25% of the original sandwich. Now your friend over here who has half of the sandwich, let's say they come across another friend who is hungry and they split their half of the sandwich and each of them get 25%. This is basically what a box and whisker plot is showing you. Alright, so just like the sandwich, on a box and whisker plot there are 4 sections. These are called quartiles, and you can think of quartiles as quarters. 4 quarters make $1. 4 quartiles make up the entire box plot. Each one represents 25%, just like each quarter represents 25 cents. Now, the reason we call them box and whisker plots is because, as you see here, this looks like a box. That's where the middle 50% of the data is. And then on either side we have these lines, and they kind of look like whiskers, and that is where the lower 25% and upper 25% lie. Okay, so on a box and whisker plot you have the lowest value and the highest value. Whatever line you see in the box is the median. Now the median is not necessarily in the middle, so as you can see here, this line is not in the middle of the box, but it doesn't matter. The line's in the box, it is the median. This line right here represents the lower quartile, and this represents the upper quartile. The width of the box shows the interquartile range, and then if you take the whole thing from beginning to end, that would be the range of all the data. And the range of all the data can also be known as the spread or the variability. So let's take a very simple example of the numbers 1 through 7, and we're going to represent them on this box plot. So the lowest value would be 1, and the highest value would be 7. Now the median would be whatever number falls in the middle, and that would be 4. So 4 would be the median. Now the lower quartile, that's going to be whatever is in the middle of the lower half. So here's the lower half, and we have 2 in the middle. So the lower quartile would be 2. The upper quartile is the middle of the upper half. So here's the upper half. 6 is in the middle, so 6 would represent the upper quartile. So if you wanted to find the interquartile range, you would just take 6 minus 2, so it has a range of 4. If you wanted the range of the entire thing, you would simply do 7 minus 1, and it would have a range of 6. Alright, so again, this is what we just covered. The lowest value is also known as the lower extreme, same as the highest value is the upper extreme. And then we have the lower quartile and the upper quartile and the median. Alright, so we're actually going to use these test scores here, and we are going to find the 5-number summary, which means we are going to figure these out for a box and whisker plot. Alright, so the first thing I'm going to do is I'm going to take these test scores and I am going to put them in order. So our lowest score is 67. Then we have 71. Oh, I'm sorry. I missed 68. 68, then 71, then 76, then we have 82, 84, 90, and we have 92. So the lower extreme is just going to be the lowest test score, and that would be 67. So while we're at it, let's find the upper extreme. That would be the highest test score. That would be 92. Now let's find the median. So we have 1, 2, 3, 4, 5, 6, 7, 8 test scores. So the median is actually going to be an average of these two amounts right here. Okay, so I'm going to take 82 plus 76. I'm going to divide that by 2 to get the median. So 2 goes into 15 7 times, and 2 goes into 18 9 times. So the median would be 79. Now if there was one number perfectly in the middle, obviously that would be the median. So whenever we have two numbers that are smack dab in the middle, we just find the average between the two, and that's going to be the median. Now the lower quartile, that's going to be whatever's in the middle of the lower half. So here's the lower half, and we've got 68 in the middle. And the upper quartile, that would be the upper half. We have 90 in the middle. All right, example 2, we are actually given a box plot of players' weights. Letter A wants to know what percent of the players weigh over 220 pounds. Okay, so we can estimate that 220 is about right here. And that would be the median. Remember, that line in the box is the median. We know that 25% of the data lies within each quartile. So that means that the second half lies here, and that half would represent 50%. So 50% of the players would weigh over 220 pounds. Now it wants to know the range of the players' weights. So we want to subtract the highest value and the lowest value. We can estimate the highest value to be about 310 and the lowest value to be about 160. So the range of the players' weights would be 150. Now the most that a player weighs, again we estimated the upper extreme to be about 310. So that would be 310 pounds. And it wants to know, sorry about that bell. All right, and letter D wants to know what percent of the players are less than 195 pounds. So we can guess that 195 pounds would be about right here. So we are concerned about what lies within this first quartile, and we know that represents 25%. So 25% of the players are less than 195 pounds. All right, now it is time for you to try, so make sure that you answer the question on Educanon, and make sure you have written everything down in your notes, and we'll see you next class day.